Let's do this LeetCode rotate array. So we're given an integer array of nums. We have int nums in here, and we want to rotate the array to the right k many steps. K is going to be non-negative, so we don't need to check for that. If we did need to though, it'd be a simple if-else in front, and you could just set it to a positive if it is a negative, or whatever it wanted you to do. So this is the method inside of our class. We can see we have two examples here. I'm going to go off this first one mainly. We have numbers 1 through 7 as elements inside of our nums array, and we're passed in k is equal to 3. So if we look at this, we are going to have the last 3 in the very front and essentially everything else after this. A way that I'm thinking of doing this, especially because if you look at the first rotation here, it basically looks like you want to move values from the back to the front. We could do this in a few different ways. One way would be to reverse the entire array so that all of the values in the back are immediately at the front. Now they're in the reverse order, but then we can reverse these values and then reverse these values so that they are in the correct position. Starting off here, we could use a collection sort, but that would take a long time. That would not be good for runtime. The best way to do this would be to make a simple private helper method to assist us in this reversal. So we can do private void, and we'll call this reverse, and we will call this whenever we need to inside of our public void rotate. Now, inside of here, we know that currently our array looks like this. However, we want to get it to look like this. So let's go into this private void reverse. To do that, first let's go into reverse. We have to pass in our data, so that's going to be our array first off. I'm also going to pass in the starting index as well as the back index. So the starting index is obviously 0, and the back index can be nums.length, so we get the entire length of this, but remember indexes are 1 less than length, so we're going to do nums.length minus 1 to get that index. Inside of here we'll have our int nums. We're going to have int front, and then we'll also have an int back. You can call these whatever you want, I'm just calling this for simplicity's sake. Now inside of here is where we're going to want to do said reversal. It's easier if we break this up into smaller chunks instead of having to look over this entire thing. We would want to reuse this method, of course, to do the other reversals. So that would be to reverse the front and then to reverse the back. So if we want to reverse the front, we would have nums reversing the front, so we start at index 0, right? Because it's reversed, we start at index 0. And then we want to go up to this value, this 5 right here, because we want to rotate only this part so it looks like this. So let's pass in nums, pass in 0. We are going to have to change this though. It's based off our k, so we can pass in k. If k is equal to 3, we're going to go 0, 1, 2, and then 3 back here. So instead what we should do is go to this last index, k minus 1. And then after that we want to deal with the rest of this. So that's going to be this 4, 3, 2, 1. So from here we should be able to do from k to the nums.length minus 1. If I can find the k on the keyboard. So we have 0, 1, 2, 3, perfect. We start at 4, and then we go all the way to the n minus 1, which will give us this last element. So let's first start with the smallest one, which is going to be 7, 6, 5. We're going to pass this into here. Now we can do this in a for loop. It's going to be pretty simple if we do it like this. I'm going to go based off this front, so I'm not going to have anything in front right here. Well, we want to run this as long as our front is less than our back. We might see if we need to modify this in a second. We'll run a test case through this. And then after we do this, well, we want to increment our front. So if we were to do this whole big reversal, once we do it one time, we're basically swapping this and this. We're going to increment, so we look at the next two values. So after this, we're going to do front plus plus, as well as back minus minus. So these are going to increase and decrease in here respectively, so we can get the next elements. Now, this is where we're going to do the swap. Like I said, we're going to want to swap this one with this one, It's going to change every time, but for the first time. Let's make a temp value to store the very first element. We'll do int temp is equal to nums, and we'll get our very front, which is going to be the front. We can't just put 0 because it's going to change depending on which elements we are passed in, so we're going to do front. Now we can set our nums front to be equal to the back, which is going to be nums at the back. After this, we can then set the nums back equal to our temp value. Pretty simple. And I'll move these over, that way you can see it clearly. That's pretty much going to be it. That's going to be the whole reversal right here. All of this. Now, if you want to run through a test case, let's do the small one right here. So, when this first happens, our front is going to be at index 0, and our back is going to be index 3. And because that's k minus 1, so that should be 2, my mistake. K is 3, so we have 3 minus 1, it's going to give us a 2 here. And then the number of iterations is currently 0. So we want to iterate this one time, increase this by 1. We go through this. Our array, the 765, is going to do an initial swap. So after the first time it swaps, I'll do it down here. It's going to look like a 5, 6, 7. And then these are going to increment and decrement respectively. So this is going to be a 1, and this is also going to be a 1. And this would be our second iteration. However, since front is now less than back, we don't need to do this anymore. This is sorted. Let's say we wanted to do this for our 4, 3, 2, 1. That's fine. Let's do it again here. Our front is going to be at index 3 because front is k, and then our nums.length minus 1 is going to give us a 6. We've gone through this iteration 0 times. Let's do this first iteration. So we've gone in this once. We're going to swap indexes 3 and 6. So we're going to have a 1, 3, 2, and then a 4. This is going to increment, so this is 4. This is going to decrement, so this is 5. We're going to run through this a second time. In the second time, we're going to have our 2 and 3 swap. So we have a 2 and a 3 here. And this is going to increment to 5. This is going to decrement to 4. So now we won't be in this for loop. Break out. We're done with this method. And our values are going to be sorted. We have a compile error because I forgot my semicolon. I'm so confident we can submit this after I put that semicolon there. Okay, one more semicolon. After I fix all the semicolons, let's submit it. And we get a array out of bounds error for something like this. So if our k is 2 and we only have one element in here, what we can do is resize our k. K would need to be 1 in this instance, because if it's 1, well, k minus 1, or length minus 1, the back of it, it's going to just be 0. So you're passing in 0 and 0, and this will never execute, which is perfect. What we can do is just say k is equal to, we don't want to just subtract 1, because changing k just with addition and subtraction is too simple and could have negative effects across the other cases. A simple way to do this is actually have a modulus equals to, and then we'll have the nums.length. And what this is doing is you're essentially saying that you're going to have the k modulus nums length, and it'll pass with 0 milliseconds. So we've gotten some good runtime, and we've gotten some okay memory usage. Some got even better. I checked in and there's this garbage collector right here. I believe that's what that is. Let's see if we can implement that right here and see if we get a better runtime. Let's submit this again with 56.96 megabytes in mind, and we've gotten even better. So that's pretty cool with the system.gc. And again, this is invoking the garbage collection, and this cleans up any memory that we no longer need. So that can result in a better runtime. Pretty cool. I'll try that out in the future, and maybe you should too. Also remember line 3, the purpose of what we're doing here is to make sure that k is in the bounds of our array length. If it is greater, then it's going to be shortened. And the reason why it worked on the last one we had, where I believe the element was -1 and our k was 2, so k was bigger, is that our length was only 1 here and k is 2. We basically had 2 divided by 1. That would give us no remainder. So this would give us 0 here, and we would not need to do any rotations. Okay, last thing. I just invoked the garbage collector more, and it cleared up more memory. So that's cool. All right, that's all. If you want more Java, check out that playlist link below the like button. We do a ton of problems. If you have any questions, as always, leave a comment below.